Hello and welcome back. In this video, we're going to verify the hyperbolic sinh addition formula, sinh of x plus y. And in this problem here, or in this identity, it is much easier to start with the more complicated side and simplify it down to the shorter, simpler side. So we're going to take the expression on the right-hand side and show by a chain of equalities that this is equal to the sinh of x plus y. So to do that, we're going to start off with this quantity, which again is the sinh of x times the cosh of y, plus the sinh of y times the hyperbolic cosine of x. And then we're going to replace it with the definition. And so the sinh, remember, is going to be e to the x minus e to the negative x over 2. We'll do the cosh in blue, so that's going to be e to the x. And actually, we're going to be using the variable y here because that identity is y. So that's e to the y plus e to the negative y over 2. And that's going to be plus the sinh definition with y. So that will be e to the y minus e to the negative y over 2 times the hyperbolic cosine definition with x, e to the x plus e to the negative x over 2. So now we want to simplify this down as far as we can, and the first step in doing so is going to be to multiply this together. So we're going to be having a lot of distributive, but for our first part of this, it's going to be e to the x times e to the y. So it's e to the x plus y. And then we have a plus e to the x minus y minus e to the negative x minus y minus e to the negative x minus y. And let's double check those. It seems like one of those might be off sign-wise. So e to the x, that minus that. Okay, so that's going to be plus right here. And then that's going to be all divided by 4, of course. And then here on this term, we're going to have e to the x plus y. We're going to have plus e to the negative x plus y minus e to the x minus y, and then finally e to the negative x minus y. Once again, all divided by 4. So since these two fractions have a common denominator, we can add them together. And that's going to be all divided by 4, of course. And we're going to have a total of 2 e to the x plus y's. And then you will notice that we have opposite signs for the e to the x minus y terms. So those are going to cancel out of our calculation. We also have the e to the negative x plus y terms having opposite signs. So they're going to cancel out as well. And then we're going to see, so we'll just put zeros in here as placeholders for those. And then back there we have 2 of the same, and they're going to have the same sign. So we're going to have a minus 2 e to the negative x minus y. And we will now notice that we can factor out a 2. So that's going to be e to the x plus y minus e to the negative x minus y over 4, which then simplifies into e to the x plus y. Then back here, we can rewrite this as e to the negative x plus y. And that 2 divided by 4 just leaves a 2 down below. And we should recognize that this is the definition of the hyperbolic sine function, but instead of having a single variable, it's got the sum x plus y. So this is equal to the hyperbolic sine of x plus y, which is exactly what we wanted to show. So if we now review our verification process, we started with the right-hand side and show that it equals the left-hand side by a chain of equalities. And that is our verification that the hyperbolic sine of x plus y is going to be the sinh of x cosh of y plus the sinh of y cosh of x.